Okay, so I'm going to demonstrate how if your data resource doesn't have a correctly populated variable in the conditions in the data binds, if you're using data binds in your condition builders, how that can result in slow performance. So what I've got here is two data resources. One is a single record, look up a single record. It is set to evaluate eagerly or immediately as soon as the page loads. It is from the incident table, and I've data bound it to this record to lookup variable, which currently has no value. And I'm just returning the number field. And then I'm going to output it into a label component, which very simply is displaying the number field value. So let's see, this is my lookup a single record data resource. I also have a multiple record lookup, and I've data bound that one to the first entry in the result array. So 1,000 arrays according to, because I haven't defined my condition, and my condition on the multiple records is that I've set parent is the same variable from the first one. And in my demo data, I've set it up so that only one record has a parent pointing to the record that I'm going to use. So let's see. Yeah, so here's how it works with the demo data, where the demo data actually has the sysID. So if you're looking in UI Builder, it has the option to put in demo data into your wireframe so you can understand. It basically shows you a mock-up of what it's going to look like when the data bind variables are populated. But if you never populate those data bind variables, then obviously it's not going to look like this. And so now I'm going to show you what that looks like. So let me refresh the page. Oh, let me save. Refresh the page. All right, and we've got considerable slowness here. We're not mapping to any result. And we're going to use a third technique here, which is I'm going to use something called session debug so we can view all of the SQL queries that are occurring as a result of our page load. So if you go to debug SQL detailed, this will open a page that says, would you like to confirm that you want to run SQL debug for just my session? So it's not going to impact all users. Administrators have access to this feature, but it's just going to run SQL debug SQL for my user, not every user on the instance. So I'll say confirm. So this has pretty negligible impact. You can turn it on in production. You can forget to turn it off. It'll turn itself automatically when your session expires. It doesn't have any, it's very safe. It's not going to cause any problems for your instance. So you can do it in production. You can do it wherever you want. Session debug, really great tool. I suggest you get familiar with it. One problem with it is it's not supported in Workspace. So if I was to reload this page right now, we wouldn't see the output, the session debug output in this page. Normally the session debug output shows up down at the bottom of the page. And then you can see what SQL on the very same page. You can see what SQL was occurring. Now there's an easy way to fix this. Is you can go to some other page that does support session debug output, load that page, and you'll see all of the queries since the last time you loaded a page that supports session debug. So there's basically a buffer for your session that stores all of the output in your session debug that occurs in your session. And as soon as you load a page that supports the session debug output, everything in that buffer will be written to the UI. So I've just gone to an imaginary page here called sessiondebug.do. And when you load an imaginary page, it loads this page not found, which happens to support session debug. So it's kind of a workaround here, but this will let me see all of the SQL queries that happened between the time that the Session debug was last output until now. until now. So what I'm looking for are the slowest queries, and you do have this helpful breakdown at the top that shows you the slowest transactions, and you also have the slowest queries. So the slowest transaction and then the slowest queries by transaction. So you can see here there was a count star query, which is going to load all matching records that match whatever the filter is in this query. Now, if you click on this, it takes you over to the query pattern, which is not super helpful. But lower down in the page, if we find the same query, we can see the entire query. You see it's truncated here. We can see the entire query. We can also see a stack trace of where it's coming from if we were going to like use this for troubleshooting purposes. So notice that so we need to like find a search term to go easily, because there's hundreds and hundreds of queries that fire every time you load a single transaction, right? So searching through all this mess is a little tricky, but one thing you can do is look for something unique in the query. And I use I know there's not too many queries to the task table here, so I look for task 0, which this little fragment of the query should only exist really on a few queries each time. At least in this scenario. Might be different in other scenarios. Okay, so here's the query details, and the first thing that I see here, task parent is null, which matches millions of records in my case. And the way that ServiceNow works is it will put a limit on your multi-record data resources of 1,000, but it's going to stream all 1,000 sysids to our backend. So you can see multiple queries here, and they're about 200 milliseconds apart. So it's streaming it's in batches of 100. So there would be 10 of these, right? 10 times 100 is 1,000. So it streams 100 sysids at a time. I'm sorry. Yeah. It grabs 100 sysids. It's already pulled back all 1,000 sysids. The second pass that we say pulls back all the other fields. So if you hover over the ... you can see what fields are returned in the query. And this is all the fields that are on the table. The first query, if we hover over these ... you can see it just returns the sysid. So the little backend knowledge, probably shouldn't share it in this. It's outside of the scope of this demo, but it's interesting. So, to understand, this is how ServiceNow works in the backend. Is we use this 2-pass method. First, we bring back all the sysids of 1,000 records, or however many your limit is. If you want to bring back 1,000,000 sysids, it'll bring back 1,000,000 sysids, but then it will paginate through those at 100 at a time, pulling back the full expanded row. Excuse me, expanded row we call it. And we query just by sysid, which is a very fast query, but the payloads are fairly large, and we're looping through them. So there's, we're spending time between each query. About 100 milliseconds here, about 100 milliseconds here. We do that 10 times. That's a full second waiting for all that to stream. And of course, with larger data sets, it'll be slower. And if this count star operation, in this case, it's a pretty efficient count star operation, but this could get much slower in a scenario where maybe you're looking for 100 records that are spread throughout, throughout the data set, and you don't have a good query for it, or whatever the case is. The count star queries can be very slow because you could have inefficient range operations, things like that. So you want to have a very targeted query, not pulling back large result sets. Let's see, we have one more query in here. Yeah, here we go. So here's where we're looking for, this should have a condition on it where it says where sysid equals, because remember, it's a single record lookup, but it's not including that condition because we didn't give it a valid sysid. So here you go. You can see at the end it does look for some sysid, but that's just because it was the first random sysid that got returned by this query. So basically, because we haven't passed it a valid sysID, it's just returning whatever random incident it happens to find that matches the rest of your filter. All right, so that's a pretty good explanation of where slowness can come from if you don't define your variables well. So next, I'm going to show you how you can overcome that by creating some logic before your data resource gets executed to make it more efficient. So here's what I've done to fix the problem. Uh, these lookups, I switched them over to explicit, which means that they will fire as soon as any of their data bind variables are changed. Every time their data bind variables are changed. So you may have to work with that. You got to understand that behavior so you can work with this. Because if you're changing the data bind variables frequently, you're going to execute data your data resource multiple times. So what I have done is put together a event, uh, an event mapping to the page ready event to call uh, a particular client script. So as soon as the page is ready, it's going to call that client script. The client script is going to update my bind variables, and I've set two different bind variables. I don't actually think I need to set two different bind variables. I thought I had to work around something because the multiple records was not getting updated until I ran this refresh operation. So the single record updated immediately as soon as the bind record, the data binding was updated. As soon as I called set state on that one. So let me see. I think I can comment out the second piece. I can connect them both to the same data bind because I had basically built a second data bind because I thought that was the problem. But I don't think that's the problem. Let me go back to using the original. Okay. And then here's what's in this. Oh, I forgot to save my changes. Apply. All right, so what's going to happen is page is going to be ready. That event will fire, trigger this client script. The client script will update my data bind variables that are connected to my data resources, and only then will my data resources go retrieve their data, and they're going to have valid values in there. And I've just put true here, but you would put, whatever conditions you need to evaluate, you'd put in here. Perhaps there's multiple input pieces that you need to do. And of course, I've hard coded a value here, but you would be getting that dynamically from some other place. So whatever your input is coming from, you'd make sure the input exists, set it, and then you would set state to that input. Set the value of your data bind variable to that input. And I can imagine a scenario where maybe what you're looking for doesn't exist, and you have to do some sort of a refresh timeout to check again a couple seconds later, or something like that. But this is a very simple example. And of course, you would change the condition that you want to have here, and you would switch this over to, instead of hard coding, you would actually have some other value that you're using for the input. All right, so apply this, save this. And now let's take a look at how it executes. Here's my page. All right, and now you can see the timings on these, 200 milliseconds per each batch request. Remember, they were taking 10 seconds. I'm going to wait a while to make sure everything's died down. I know it has, but I'm just going to wait for a moment. And then I'll refresh over here. Actually, let me do that one more time. Okay. So yeah, everything loaded nice and fast. These things way over here are not, they weren't waiting on anything. It wasn't a long request to the server, and the UI wasn't frozen. These are, yeah, this is the interactions call, the metric. These are asynchronous to the page load. They happen afterwards. You can see I've got the outputs populated here for the multiple lookup and the single lookup. And let's check and see what slow queries happened or what the queries were. So this one is for the multiple lookup. You can see it's got parent equals and limit 1,000. There's only one record that matches my query. Only one record gets displayed. This is super fast, less than 1 millisecond to execute that operation. And yeah, maybe this is the other one. It doesn't have parent ID equals. But no, it's a different sysid. This one is for the single record here. Yeah, see, this is the sysid A407. That's the hard-coded one for the single record lookup. Yep. Also, I mean, totally negligible. Less than a millisecond for all of these. So there you go. That's one way that you can avoid that missing variables problem.